Now, in preparation for Theorem 2, we need to know what it means to subtend an angle. To subtend an angle, dictionary defines that as to be opposite and delimit the extent of an angle or side of a geometric figure. Now let me demonstrate what that means for you. If you have a line AB, watch that. Can you see that? That angle C practically originated from the edge AB. Now if it is an arc, watch, see that? That's the meaning of subtend. That's to delimit. Okay, that's why the dictionary defines that as to be opposite and delimit the extent of an angle. So the angle C virtually originated from AB. Now if you have a line can actually generate more than two angles. Can you see that? So all those angles C, D, B were all subtended by the line AB. If it can also be an arc sustaining more than one angle there. Okay. Now we are going to inspect a major arc and the angle it subtends. Now note that if this is a major arc, for instance, for a major arc to subtend an angle, that's the angle. Okay, so that's the angle subtended by a major arc. Alright. Now the major arc can also subtend the angle inwardly. That angle was also subtended, but it is actually the inward angle, which is the reflex angle that was subtended by the major arc. So a major arc will only subtend a major angle inwardly. Can you see that? So that's the region I'm talking. So therefore a major arc will either subtend an angle outwardly or inwardly. When a major arc subtends an angle inwardly, that angle is always a reflex angle. That's what we have seen there. Now we have a quiz here. How many arcs are here? How many arcs can you see? Well, we have two. That's one arc, a minor arc. That is second arc, a major arc. Okay, so that's it. So that angle was subtended by the minor arc. Can you see that? The angle there was subtended by the minor arc. That angle was subtended by the major arc. Y was subtended by the major arc. Now which of the arcs subtended X? Of course the minor arc AB. Okay, that's it, the minor arc. Which of the arcs subtend angle Y? The major arc AB. Okay, so it's good, you must know this distinction, because it's going to be very helpful. You must know the difference between a minor arc, the angle subtended by a minor arc, and the angle subtended by a major arc. Okay, Y was subtended by the major arc inwardly. Okay, now we have Theorem 2, which is one of the most important theorem in this particular topic, which says that the angle which an arc of a circle subtends at the center is twice that which it subtends at any point on the remaining part of the circumference. Okay, now we are not going to prove any of these theorems. We are not going to prove it. We are only going to demonstrate them to you. That's the essence of this video, to give you animations, graphical demonstrations of these theorems. Now the best way to understand this theorem is to have a rephrase of it. It means that the angle which an arc subtends at the center is 2 times the angle which the same arc subtends at the circumference. Let's see what that means. Now with a minor arc, and we are given a circle with center O. If we have a minor arc there, AB, and AB sustains one angle at the center there, and the same AB sustains another angle at the circumference at point C. The angle at circumference, the angle at center, if the angle at circumference is x, the angle at center is 2 times of x. So that's just what the theorem is saying. So if the angle at circumference, okay, that's it. That's to tell you that all the two angles, they came from the same arc. So if the angle at circumference is 20, the angle at center must be 2 times. If the angle at circumference is 10, pardon, the angle at center must be 2 times of 10, which is 20. So now if the angle at center was is 100, then the angle at circumference must be what? Half of 100, which is what? 50. So that's what that theorem is saying. Okay. Now case 2, also with a minor arc. Given a circle with center O, and we have a minor arc AB, if this minor arc is to sustain an angle at the circumference, and the same minor arc sustains another angle, let's say the angle at circumference is x, and the same minor arc sustains an angle at the center. Can you see that it's quite different from the previous diagram? Okay, but still the two angles are still coming from the same arc AB. So one is at the circumference, one is at the center. So if the one at circumference is x, the one at the center must be 2 times of x. So let's see that. So yeah, those two angles came from arc AB. Okay, that's it. That's what's demonstrating there to you. So if that angle is 15, then the one at the center must be 2 times of 15. Okay. So if that angle is 50, then the one at circumference must be half of that, which is 25. So this is case 2 of the same theorem. Let's look at case 3. Now case 3 with a major arc. Given a circle with center O, but this time we have a major arc. Can you see that? That's the major arc. The minor one is up. Now if that major arc is to sustain an angle outwardly, can you see that? That angle came from that major arc outwardly to the circumference, and that same major arc is to sustain another angle, this time inwardly, and that is the angle there. Remember we covered that in the other section. If that angle at circumference is x, then the one at center must be 2 times of x. Okay, so note that there are two angles at the center of the circle. One was subtended by the minor arc AB, while the other was sustained by the major arc AB. You know, at angles at a point, there are actually two angles there. Okay, note that the difference, and note the one that was sustained by the major arc. The way to distinguish these two is that a major arc will always sustain the major angle at the center, while the minor arc will sustain the minor one at the center. So let's see that now. If that angle is okay, so those two angles came from the same arc, which is the major arc AB. So if that is 102, then the one at the center must be 2 times of that, which is 204. Okay. So if that is 112, then the one at the center must be 224. Now we have an example here. In the figure below, A, B, C are points on the circumference O. If angle AOB is 150, calculate angle ABC. Now we have an arc AC, subtend an angle at center 150, but that angle came from the major arc. Okay. Now we are asked to calculate the angle at B. Now, which arc subtend 150? Is it arc AB? Is it arc BC? Or is it arc AC? We notice that it is not arc AC that sustains angle ABC. Okay. Now the major arc AC subtended angle ABC at the circumference. Can you see that? And a reflex angle at the center. Now that's the angle subtended at the circumference by the major arc. And that's the angle subtended by the major arc at the circumference. So if we must find that angle B, we must find the reflex angle, because both that angle and the reflex angle came from the same arc. Okay, so we must find there's a relationship between those two, and that relationship is that angle at center is 2 times angle at circumference. Now we use angles at a point to find reflex AOC. I have called it reflex because there are 2 angles there. I cannot just say AOC. Remember, AOC is also 150. So if I say AOC, I'm talking about 150. But when I say reflex AOC, then I'm talking about the one flashing. So AOC reflex is equal to 360 minus 150, which is 210. So 210 angle at center is equal to 2 times angle at circumference. Angle at center 2 times angle, because they came from the same arc. Okay. So 210 will be 2 times of ACB. Now if I divide both sides by 2, I will have my ACB as 105 degrees. Okay. So it's very important you know which arc is subtending which angle. If you are looking for an angle, you have to first locate the arc that subtended it and check if that same arc sustained another angle that has a relationship with that angle. Okay. Now we have a quiz here. How many arcs are here? How many arcs can you see? Well, we have 2. That's one arc, a minor arc. And that is the second arc, a major arc. Okay. So that's it. So that angle was subtended by the minor arc. Can you see that? The angle there was subtended by the minor arc. That angle was subtended by the major arc. Y was subtended by the major arc. Now which of the arcs subtended X? Of course the minor arc AB. Okay, that's it. The minor arc. Which of the arcs subtend angle Y? The major arc AB. Okay, so it's good. You must know this distinction, because it's going to be very helpful. You must know the difference between a minor arc, the angle subtended by a minor arc, and the angle subtended by a major arc. Okay, Y was subtended by the major arc inwardly. Okay. We have another example. We have there is a circle, center O. We have an arc, subtend an angle at center there, subtend another angle at circumference, and that's a chord. Okay. Now we are told to find the size of ACB. ACB is the one at the circumference there. Now note that we have an isosceles triangle here, because AO is equal to BO by length. They are radii, okay? Can you see that flashing? So those two lines are equal in length. Okay? So those are radii. Now that angle is equal to the other angle. Base angles of isosceles triangle. An isosceles triangle has two base angles. Now what am I trying to do? I'm trying to get the angle at center so that I can find the one at the circumference, which is ACB. Okay? So I can now use sum of angles in a triangle. So AOB, which is the angle at center, is 180 minus the sum of the two base angles there. So that will give me 108 degrees. So that angle at center, okay, can you see that? One is at center, one is at circumference, and they are from the same arc. So AOB, angle at center, is 2 times angle at circumference. Okay, and AOB is 108. So by the time we divide both sides by 2, ACB will be 54 degrees. Okay. Some students get confused, as in they don't know when to multiply the angle by 2, when to divide by 2. Well, the truth is this: just say which angle is at center and which one is at circumference. The one at center will be equal to 2 times the one at circumference. It's as simple as that. So it depends on the angle you are looking for, the unknown angle. That will determine whether you are multiplying or dividing. But just get the relationship: angle at center 2 times angle at circumference. Okay. Now we have a lovely quiz here. We are to find the lettered angles in the figure below, given that O is the center of the circle. So that's some hints that I'm giving you there. I'm giving you hints there. And that should be your answer as well. Now we have under one on the screen there, number 2. Hint. That's your hint there. And that should be your answer as well. Now what you must note about this theorem is that for this theorem to hold, one arc must sustain an angle at center, and the same arc must sustain another angle at the circumference. So there must be a center, a reference to the center of the circle before this theorem can hold. Okay.